The moon has long been considered an inert place where the lunar dust is only disturbed by the occasional impact from a meteor. But researchers have discovered that, despite not having its own atmosphere, the moon may experience weather of its own. They have found the stream of particles thrown out by the sun in solar wind appears to interact with the moon in an unexpected and surprising way. On Earth, these particles interact with the gases in the atmosphere to create colorful aurora, while the planet's magnetic field concentrates it around the poles. The moon, however, lacks both an atmosphere and a global magnetic field, and so was thought to passively absorb the solar wind without any noticeable effects. Measurements made by India's Chandrayaan-1 lunar orbiter have now revealed this is not the case, and in fact 10% of the solar wind is reflected back into space. This creates turbulence in the solar wind streaming past the moon, causing vortexes that billow onto the dark side of the moon, which should be sheltered from weathering by the solar wind. The researchers said this could have important implications for how much water may exist on the surface. Charles Liu, a researcher at the Swedish Institute of Space Physics at the Umeå University, who conducted the work as part of his PhD, said, "This knowledge is of great importance to the lunar space environment, which is affected both on the lunar dayside and nightside surfaces. The effects can even be seen in the form of visible light, like bright swirls imprinted on the surface of the moon. The observations help us map and understand the variations in the lunar space environment. They also give us clues about the physical processes involved and the long-term effects they have on the lunar surface." Mr. Liu found that the reflection of the solar wind interacts with areas of localized magnetic fields on the lunar surface. In areas with strong magnetism, caused by iron in the crust, the solar wind flow is restricted, while adjacent areas receive increased flow. This results in unusual spirals of ions streaming off the day side of the moon, where the solar wind strikes first, to the night side. Mr. Liu said it appears the weathering of the moon's surface by the solar wind may be less than previously predicted, and this could mean there may also be less water hidden beneath the crust. He said, "The reduced solar wind weathering allows us to separate micrometeorite and solar wind-induced weathering, including the effects of different solar wind species, differently well shielded."